Hello everyone. So there is another question from Resnick Halliday's 10th edition. This is chapter 9, question number 70. So the question reads, in figure 969, puck 1 of mass m1 0.2 kg is sent sliding across a frictionless lab bench to undergo a one-dimensional elastic collision with stationary puck 2. Puck 2 then slides off bench and lands a distance d. It has been marked in the diagram. You can see that distance d from the base of the bench. Puck 1 rebounds from the collision and slides off the opposite edge of bench, landing a distance 2d. 2d is also marked here from the base of the bench. So they want to know the mass of puck 2. So now it has a very simple solution. It involves conservation of energy and conservation of momentum because the collision is elastic. And we will be concerned with the horizontal velocity. Horizontal velocity doesn't undergo any acceleration and it covers a distance 2d for puck 1, and for puck 2, it covers a distance d. So I'll hand over to Satvika. She will explain how this solution works for this problem. Okay. Yeah, Satvika, go ahead.
Okay, so they gave us the mass of M1 as 0.2 kgs. So okay, and they said that this M1 mass, once it collides, it moves a distance of of 2d. But then because it moves in the left-hand direction, we're going to put d1 as minus 2d.
Perfect, very good. It is as per the Cartesian rules. Like you measure on the number line, anything on left hand side is negative, and on right hand side it is positive.
Yeah, and because of the this is an elastic collision in one dimension, so we can find the velocities after the collision as v1f will be equal to m1 minus m2 by m1 plus m2. This times v1I, which will basically be the velocity of the first mass, the initial velocity of the first mass. And so this is just for the first mass after the collision. Now for the second mass, we don't know its mass, so we're going to put m2. We're going to leave it like that. Oh,
yeah.
I can't write with a mouse. And
Okay.
d2.
You can use your hands to do that. It will be easier.
It's not working. I tried.
Okay.
Oh, I know it works. Ah, scam. Okay, d2 will be 2. Oh, Lord. Right. Yeah. And d2 is equal to 2m1 by m1 plus m2. Oh, sorry. Sorry.
This is V2F, right?
Yeah, this is V2F. I wrote it the other way around. Sorry, this will be D because they said in the question that the second mass, once after the collision, it drops at a distance D. So that is our distance D. And then we have V2F as 2m1 by m1 plus m2 times V1I. Okay, so because this is an elastic collision one dimension and horizontal, and this is on the horizontal axis, so x-axis. That means we know that d will be equal to v times t, right? So when we do it for each of these masses, how do you move it? Oh, you can't move it.
Okay, anyways, you can directly, you have space on right hand side, little bit. So you can write minus 2d equals to v1f times t. Yeah, so we have v1f and v2f. Now what next?
Okay, so we're going to find, because this is in what this is one-dimensional elastic collision. That means we can say that displacement will be equal to velocity times time. So when we
Yeah,
do
basically it
this
is the
for
horizontal
mass
distance.
one,
Basically it is the horizontal distance. So it will not undergo any acceleration. Okay, only vertical motion will undergo acceleration.
yeah,
Yeah.
yeah. So for mass one, the distance, this entire equation will be minus 2d is equal to m1 minus m2 by m1 plus m2 v1I times t.
Correct. Very good.
Okay, and for the second mass, m2, we'll have d is equal to 2m1 by m1 plus m2 v1I t.
Perfect.
Because both of them, because they're both are dropped from the same height, then both of them will have the same time period. That's why we take t as the same thing. So
Perfect. Good.
now when I'm doing with, so these two will be our equations, and we're going to solve these equations. So I'm going to divide this equation 1, by equation 2.
Right.
So when I do that, this entire problem will be simplified. So d by minus 2d is equal to 2m1 by m1 plus m2 v1it.
Times
Wait,
m1
I'll
plus
move it.
m2 divided by 2m1. Right? No, no, no. M1 plus m2 divided by m1 minus.
By m1 minus m2 by m1 plus m2 v1it. This entire thing is the division mark. Okay, so when I do this problem will be simplified. D cancel, v1it and v1it cancel. So when you do that, you'll get minus half is equal to 2 times m1
Divided by
by
m1
m1
minus
plus
m2.
m2.
M1 minus m2.
No,
You will
wait.
get cancelled, right?
Times m1 plus m2, because when you simplify a complex fraction, the it reciprocals, right? m1 by m1 minus m2. Okay?
Correct.
Yeah. So we cancel this and this. So it'll be minus half 2m1 by m1 minus m2. Since we already know the value of m1, we can simply substitute the value, which is 0.2. So minus half 2 times 0.2 by 0.2 minus m2. So here, because this is equal to, we can cross multiply both of them. So this will basically be minus of 0.2 minus m2, which is equal to 2 times 2 times 0.2. So when you do
You get
this,
m2 as 1
you will
kg.
get,
That's m2 as 1 kg.
yeah,
1 kg. That's
dun dun dun.